Hi, I'm Rob Pye. I'm the CTO for IBM Watson, and we're going to talk about something that I'm really excited about. We have a project going on here that we're going to talk to you about that I think you're going to find really fascinating. But before we get started, let me get everybody to introduce yourselves. This is the team that's working on this idea that I think is going to have a tremendous impact on society. So Tanmay, tell us about you.
Sure, so hi, my name is Tanmay Bakshi. I'm in the 8th grade and I live just outside of Toronto in Brampton, Canada. I am a software and cognitive developer as well as an algorithmist, author, keynote speaker, and YouTuber. I'm also an IBM champion for cloud and an honorary IBM cloud advisor.
Perfect.
Terry.
I'm Thierry Hubert, CEO of Darwin Ecosystem. We're a technology company who specializes in pattern detection and cognitive solutions.
Excellent. Tim.
Yeah, my name is Tim Duncan. I'm a Bluemix specialist here with IBM, have been for the last 2 years, and I specialize in helping clients take ideas off their brainstems and deliver them as applications in the cloud.
There you go.
That's true.
Darren.
I'm Darren Goodjohn, president of Not Rocket Science. We're also a business partner that is focusing on bringing emerging technologies to our customers like the cognitive computing, blockchain, IoT, and this project just ticks off a lot of those. So we're really excited to be working with.
So Tim, you were on the front line when this idea started coming out and forming.
Right?
Tell us a little bit about it. What's the idea here? What's the project?
Right, so I told you I'm a Bluemix specialist, so entailed in that I'm kind of a master of connections, so to speak. So I'm on the front lines in a customer communication tool where Twitter messages come to my front doorstep. And a Twitter message actually started this project from a group that was advocating for this cause. And I took that message, and since I knew the right people, I surrounded and kind of created sort of an innovation ecosystem, so to speak, with all the best developers that I know, which are these 3 individuals right here. And then as time progressed, you ended up hearing about it, and we are here now.
Yeah.
It's amazing.
So, Tim, you reached out to these guys, and Terry, I know that you have a technology that you've been working on that is directly applicable to this. So first of all, set us up. What was the problem? What is it that that we're trying to address?
Well, the problem was, at first when Tim brought it to my attention, this quadriplegic was not communicating with the world, and yet somebody had suggested, can we use IBM, can we use Watson to make our life easier, to just even provide mobility? And one of the first thing I asked, well, wait a second, if this is somebody who's a quadriplegic, we have a problem with communication, with language, with expressions. And what can we get that would give us data? And we specialize in pattern detection. So EEG signals seem like the right thing to do, but it was not enough. Because as you may know, people who actually interact with these types of technology teach the technology what to say.
Yeah.
So I told him, I said, Tim, what if the mother was the intimate interpreter that would teach the system what the intention of her child is so that we could map it and mark it against the EEG signals? And that's really what got it going, actually, is from that perspective. And we started to go to work and build the technology and reached out and had a lot of fun.
Exactly.
And Tim, you came in knowing something about analytics and algorithms and the techniques that we might be able to apply to interpreting what this girl might be thinking as that is sort of measured through the EEG device, correct?
Exactly. And so as I said, I'm a cognitive developer, and I absolutely love to work with cognitive technologies, not only provided by Watson, but my own custom algorithms as well, custom implementations such as neural networks and other machine learning algorithms. And so basically, I guess you could say my role and my interest in this application and sort of what I'm doing here is basically taking the EEG brainwave signals that Theory provides to me and trying to find patterns. And like, for example, let's say we're giving the girl the ability to communicate and to communicate her decisions and to express herself. Then in that case, we might want to have a neural network or some other machine learning algorithm that can find patterns between, okay, what makes a yes in these EEG brainwave signals, and what makes a no in these EEG brainwave signals, so that we're able to take new brainwave signals and process them and say, okay, the girl's probably thinking of a yes right now or a no right now with a certain level of confidence.
Right. And yes or no are kind of basic forms of representation of expressing ideas, right? Could get a little more complicated than that too, right?
Yeah.
Yeah, exactly. Those EEG brainwave signals are completely capable of providing all of that information. It's just that we're starting off with one of those more simple examples so that we're able to, I guess you could say, drive across the point that it's possible. Then once we get that, we can expand as much as we possibly want to.
And that's true, and that's exactly right. It's the pattern detection and the learning system. Because when it's assisted by the mother reinforcing the intention and the system remembering it, we can turn those signals into different forms of expression, either text to voice so that we can verbalize the thought, or text to command so we can operate machinery.
Yeah. That's where you and I have been working on some natural language interfaces, and when I heard about this, it was like, I want to be involved with this. 'Cause I sit on the board of New Heights Therapeutic Riding Center, and it's basically, you use a horse in therapy, and one of the problems they have is actually quantifying the benefits that you get from this. So when I saw what y'all were doing, I figure if you take the EEG technology along with some body sensing networking type of IoT with, acceleration, how much muscle energy they're exerting and so forth, we can begin to actually track and show the progression of a rider.
And make the correlation.
Yeah, and there's so many spin-offs of this stuff.
Right, because it really is not just about this case, which is sort of, it's an enormous task in its own right, but if we can get to the point where we can understand people by the way that they think, how much more can we understand a person when we understand their entire body, their entire physiology?
And in the equine therapy, it's part mental and also the physical. So to be able to show both, that the difference between riding a horse and getting therapy or being underneath fluorescent lights in a hospital room or something, it's totally different. We'll be able to, I think, be able to prove that.
Yeah, and that's it, because you have to be careful with this. We're talking about signals that are really being read with interpretation. And when we cross-correlate and we get all this IoT data plus the EEG, the EMG, and we put all of it together, it is a form of expression.
Yeah.
And we have to make sure that there's a valid validation life cycle and a learning system. So that one person is going to create a corpus of knowledge and expression that is going to be unique to them and their patterns. And this is the magic.
Exactly.
Right?
And really, go ahead.
Sorry. Yes, just as Thierry mentioned, basically, to simplify this all, what's going to happen is we have the intimate interpreter, the girl's mother, and who's almost the only one who can actually almost completely understand the girl and what she wants. And basically, we're going to have her act as basically the trainer for the neural network. And basically, we're going to have the system that can display, even when it's not trained, what its prediction is. And the mother can actually say, that's wrong and that's right. And it'll eventually teach the neural network to understand when the girl is saying yes and when the girl is saying no.
Yeah.
And so in that sense, we're basically teaching the neural network through example how to classify between the yes, no. And of course, from there we can expand.
I mean, and it really kind of fits into the whole premise of cognitive computing, which is largely about, finding the signals, the patterns and signals that represent meaning.
Exactly.
And of course, when we apply that normally to language, trying to interpret and understand what people mean in their language, this is taking another form of expression and attempting to find the same patterns of meaning, but in a completely different form.
It's the most intimate form of it, if you so to speak, augmenting humans, providing assistance to them. This is such a unique way to do that, I feel like,
And we're doing something really wonderful with this, right? I mean, this is augmenting communication. The whole thing of this cognitive computing is about augmentation, and paired with statistics and whatnot, we're really doing something fun here.
Exactly.
And the application is so varied, but this case is fascinating because from a scientific standpoint, we're really looking at gathering data and doing pattern detection and analytics.
Exactly.
And use case is good.
Guys, let's make this a little bit personal too, though, right? Because I mean, this is a girl who today has no way of expressing herself to the outside world. She has no control of her physical capabilities to articulate, her language, her vocalization, anything. And so for anybody trying to understand her, as you said, the only one that could really do that well is her mother, but for everybody else, there is no real communication going on there. So for her, and Tim, maybe you can comment on this, I mean, think about what that life is going to be like when suddenly she can find a way of communicating her own thoughts, her own wishes, her own intentions in a way that a much broader audience can now understand.
Sure, so my experience when we went and met with them, she was very limited, obviously. Has to have help in every aspect of her life. Even moving somebody out of the way to see the TV. She can't even do things like that, you know? So she's totally dependent on her mother and her handler, and as a result, I think that this communication could, you know, obviously unlock her brain, so to speak, her mental thoughts in a way that allows her mother to finish her quest, which is kind of an impassioned quest to help her 29-year-old daughter get to the point where she might be able to communicate beyond basic eye pointing.
Yeah.
I think the possibilities that solution provides could be absolutely groundbreaking in terms of an innovation perspective.
Yeah, and Darren, you were referring to this earlier too. I mean, and not just for this one girl, but if we can now take it to all the other cases where, for one reason or another, people are not able to do everything they want to do.
It's my sister's brother-in-law, you know, the family, blah, blah, blah. But he's got cerebral palsy. And you know, I can talk to him, but I don't have that intimate relationship with him. When I come into the room, he sees me, he wants me to come hang out with him and talk to him, but I have to get somebody else to tell me what he's saying. And I've been promising forever that he's going to start going on these 5 and 10K runs.
Yeah.
And I'm worried that we're 3 miles into a run and I can't communicate with him.
Yeah.
This thing may totally eliminate that barrier. Because right now, John's got to run with us because he's the only one that can communicate. Right. But we plan on using it for that.
Yeah, and so you see, that's why this system is so great. We're taking someone who used to have, when she was very young, the ability to communicate and the ability to express herself and communicate her decisions, her emotions, and more, not completely naturally, but over time that deteriorated, and now she no longer has the ability to really, you know, express something, anything at all.
Right.
And so we're basically taking the fact that she's unable to communicate naturally, and we're basically augmenting her capability to communicate and amplifying that through artificial intelligence, through cognitive computing, in order to give her that ability to communicate, to give her that ability to express herself. And of course, this isn't just for, you know, one person. This can be taken up to a much larger scale with so many more people, as Darren was just mentioning.
It really kind of changes the definition of universal translator, doesn't it?
Oh, yeah, kind of. But did you sense when we were there, I mean, when we were and we met her, and there was her assistant, right, or caretaker, and she said, she had been there for 2 years taking care of her, and she still needed the mother to tell her what exactly she wanted. Yeah. And I told her, I said, can you imagine this wonderful tool you have, the human brain? Even after 2 years, it is difficult for you to really read those signals because she's so locked inside. And that was really emotional for us. I remember when Tim and we drove out, and we had a moment, it was snowing, it was the end of the day, it was a blizzard, and we felt isolated, and it was a metaphor that encompassed the insulation of what this person must be feeling, and to think that we could even play a small role in helping her express herself to the world with the work that we're doing together as a team with Tim's brilliant understanding of algorithms and pattern detection, which is what I'm passionate about. You know, with Tim's ability to put this thing together, with you coming in and being a mentor and an advisor to us, and you taking it to other levels with bringing IoT in this, it's wow, it's wonderful.
So Tim, close us up here. This is a story, right? This is just the very beginning of what we expect or imagine will be an ongoing conversation, evolution of technology, adaptation of that technology to no more use cases. How's this going to proceed?
So my thoughts, we've talked briefly about this, but you know, I'd really like this to be an open project. I don't think us four could be responsible for solving disabilities. So I would love for this story to empower the developer ecosystem to come and help us train this data, improve these algorithms, and ultimately provide innovative solutions for every type of disability. So eventually we would have, you know, one chapter within this overall story. The focus right now is improving the lives of humans with disabilities through innovation and technology, and hopefully through some of this core pieces that we would make available to the open community. Hopefully that will allow people to come build value stack solutions on top of there for other disabilities.
Exactly. So you've created a community. You've created a place where people who want to participate can come.
Right.
Where is that?
Okay, so I've created a website called thecognitivestory.com, and essentially it's a place where anybody can come follow our progress, see updates on more sections to our story. They can see some of the solutions that we've developed, understand how to get to the GitHub documentation that we will be putting up, and then there's also ways where you can actually engage with us. So Instagram is one of them that I picked, and then also Slack. So Instagram is where I'll post pictures related to this story. I feel like pictures is the best way to tell a story. And then in addition to that, Slack is a way where we can kind of create a community throughout this. And so if you come into this community and you type in a public channel, that's great. We would love to interact with you, but we are looking for people who are going to be committed to this cause, and eventually we would bring you more behind the scenes with us and create a channel in there, and we would interact and work on a regular basis like that.
Excellent, very good. So I want to thank you for joining us today and being a part of our story. I want to invite you, be part of this story, follow what's going to happen here, see how that progresses, and thank you again for your time and attention.